Okay. So, class now, we are still dealing with the Earth system, no? Again, we're still dealing with the Earth system, and since we are considering Earth as a system class, no? Ulitin ko, let me repeat myself. We are dealing with Earth as a system. And since we are dealing with a system here, pinag-usapan natin dito is the Earth system. We are dealing with a system. We would expect na sa Earth system natin, meron tayong matter and energy. So tatandaan nyo, in every system, there is a presence of matter and energy. In class ha, let me repeat myself. In a system, there is always a presence of matter and energy. And yung Earth nyo, dahil isa siyang system, it is an example of a system, we would expect na sa planet Earth, meron din tayong matter and energy. There is also matter and energy in planet Earth. Now, before we before we begin discussing the matter and energy in the Earth system, paano ba natin i-define kung ano yung system? Let us first define what a system is. Ano ba tong system na to na tinatawag natin? Okay. Sige nga, any idea? Ano ba yung system, class? What is a system? But you hear it already, your organ system, the computer system. So technically, what is a system, Sean? Ano yung system na? Sean, what is a system?
A network of relationships among a group of parts, elements, or components that interact with the influence one another through the exchange of energy, matter, or information.
So yun yung nakapresent sa screen ko. That's why you read, no? What is a system? Pero based on your understanding, ano yung system, Sean? Ano ba yung system? For you, for based on your own understanding, ano ba tong system na to? What is this system, Sean? Sean, based on your understanding, ano yung system na?
Interconnecting networks or parts of mechanism.
So in short, pag meron ka system, marami kang there are what?
Procedures, sir.
Procedures. Sige, when we're speaking of circulatory system, paano naging system yung circulatory system? Because circulatory system itself is also a system, just like an earth system. Pero tanong ko, paano naging system yung circulatory system? How did it become a system? How did it become a system? Sige nga. Any idea? Sean? Paano naging system yung circulatory system? For example, how did it become a system? Based on what you read na, di ba? You just read to us ano ang definition of system. What is a system? Now, based on the definition, based on your own understanding, ano yung system? Sige, to help you with that, kindly look at your circulatory system. Your circulatory system is an example of a system. Bakit naging system ang circulatory system, Sean? How did it become a system?
Kasi nagwo-work sila together, sir.
Okay, kasi meron siyang mga individual components that are working together. So technically, pag sinabi mong system, system class is actually comprised of multiple parts and these multiple parts should work together. Tulad na sa circulatory system nyo, meron tayong heart, blood, and blood vessels. And this heart, blood, and blood vessels work together class to perform a function of a system. At yung tatawag nating system. Now, when we are saying system, it is comprised of several or multiple parts working together. So, yun yung tinatawag nating system. Okay? Did you understand, class? Now, class, I think I already introduced to you what is a system. Let us examine how matter and energy flows through a system. Saglit lang. For a while. So class, now we have just discussed what is a system. Ngayon class, let us look at how matter and energy flow through a system. So tatandaan niyo class, yun nga, dahil we are speaking of system is comprised of both matter and energy. Ulitin ko ha, system is comprised of both matter and energy. Okay. So, yung system natin, it's comprised of both matter and energy. And class, paano sila nag-flow sa system? In terms of matter, class, yung matter natin sa system, it is flowing in a cyclic manner. So, cyclic class, ha? Ang flow ng matter natin sa system, specifically, we are speaking of Earth system, ang flow ng matter natin sa Earth system class, or the system itself, is cyclic. So pag nag-flow yung materials class sa Earth system, it should be in a cyclic manner. Tulad ng water cycle, di ba? We just discussed the water cycle, the carbon and oxygen cycle, the nitrogen cycle, sulfur and phosphorus cycle. And those are materials or matter. And if you would observe, class, yung ating mga water, carbon dioxide, oxygen, sulfur, phosphorus, yung ating matter, it flows sa Earth system in a cyclic manner. In a cyclic manner. Kaya nga meron tayong water cycle, di ba? It just shows that water as a material found in the Earth system will flow in a cyclic manner. Samantalang class, ang energy, if matter flows in a cyclic manner, yung energy ninyo, it flows in a linear manner. So yan tatandaan ninyo ha. In the Earth system or in the system itself, no, yung matter natin, it flows in a cyclic manner. Samantalang ang energy ninyo, it flows in a linear manner. And plus, in order to fully understand yung flow, in order to fully understand the flow of energy and matter, specifically in the Earth system, we must understand that meron tayong tatlong klase ng system. So let us imagine class, let us say, meron tayong tatlong flask dito. We have 3 flasks dito. Unahin natin yung unang flask. Sa unang flask, nakabukas siya. At dahil nakabukas yung unang flask, no, pwedeng pumasok yung matter at pwedeng mag-exit yung matter dito sa butas. No? Matter can enter and exit through this system, and also, aside from matter, pwedeng mag-enter yung heat natin at mag-exit yung heat natin in this kind of system. And in this case, no, yung sa unang flask natin, in the first case that we have, if you would observe, matter can enter and exit this system, and heat can enter and exit this system. And if that is the case, tatawagin natin itong system na to as your open system. We would call this as an open system. At open system siya since matter can enter and exit through the system, and heat can enter and exit through the system. In short, when we are speaking of an open system, we are speaking of a system where both matter and energy can enter and exit. So tatawagin natin yan as open system. Ngayon class, let us examine the second one. Let us say sa pangalawa, binigyan natin siya ng rubber stopper or ng cork stopper. And since meron na siyang rubber stopper or cork stopper, hindi na makaka-enter at makaka-exit yung material. Ano nila makaka-enter and exit? Ang makaka-enter and exit na lang would be your heat energy. And if this is the case, if heat energy can enter and exit but not matter, so tatawagin natin itong system na to as your closed. We're going to call it as your closed system. So pag sinabi niyo class na closed system, this is a kind of system where heat can enter and exit but matter cannot pass through this kind of system. So tinatawag siya na closed system. Ngayon class, let us go to the third one. Let us say itong pangatlong system natin, may insulation siya tulad sa thermos nyo. Sa thermos nyo kasi may flask yun, tapos it is covered with an insulation. So let us say this is an insulation, no? Insulation to, and this insulation covers your flask. And aside from the insulation, meron rin siyang rubber stopper or cork stopper at its soul. And if this is the case, no, hindi pwedeng mag-enter and exit at material at maliban doon dahil insulated siya, hindi rin pwedeng mag-enter at mag-exit ng heat energy. And if that is the case, tatawagin natin class yung ganitong system as your isolated system. We are going to call this class as your isolated system. And pag sinabi yung isolated system, it is a type of system where both matter and energy cannot enter or cannot exit. Now, the question is, ano bang Earth? Palagay ninyo. In terms of matter and energy, what is Earth? Is it an open, a closed, or an isolated system? Okay, Samantha Arcilia, what do you think? Anong planet Earth? Is it an open, a closed, or an isolated system? Sam,
Open systems.
paano mo nasabing open system yung Earth? Sam, can you explain further? How did you say na open system ng Earth?
Sir, I think kasi kaya open system yung Earth kasi kaya niyang mag-process ng different processes or cycles.
Okay, kaya niya mo process ng different processes or cycle. Tatandaan mo sama, pag sinabi natin open, closed, and isolated system, we are referring to yung pag-allow ng system na mag-enter at mag-exit ng heat and matter. So in this case, no, sa open system, pwedeng mag-enter at exit ng matter at ng heat energy. Pag closed system naman, it would not allow matter but would allow heat energy. At sa isolated, both heat and matter cannot enter or exit the system. In the case of planet Earth, ano kaya yung planet Earth? In case of planet Earth, sige nga, i-analyze natin Sam, yung matter, pwede pang mag-enter at mag-exit ng matter sa planet Earth? Sam, do you think can matter enter and exit the planet Earth? In its natural, when we are speaking of natural processes, so we are speaking of walang interference of human, can matter enter and exit planet Earth?
No, sir.
Hindi, no? Hindi naman kasi pwede mag-exit yung gases na nasa planet Earth. Hindi pwede mag-exit yung water or liquid water sa planet Earth because it's being pulled by your gravity. So meaning matter cannot enter or exit. Pero yung energy, Sam, pwede bang mag-enter and exit ng energy sa planet Earth?
Yes, sir.
Yes, di ba nga? That's why we are receiving sunlight coming from the sun, or radiant energy coming from the sun, since it allows the entry of energy and also it allows the exit of energy. In short, Sam, ano ang planet Earth? Is it an open, a closed, or an isolated system?
Closed system.
Okay, it's a closed system because it would not allow matter to enter and exit due to gravity, pero it would allow heat to enter and exit through its system. So that's why we consider planet Earth class as a closed system and not an open or an isolated system. So let me go back now to my PowerPoint presentation. Ayan, so those are the difference between the closed and open system, and also I already introduced to you the isolated system. And tulad nga ng sabi natin, planet Earth is a closed system. It will not allow the entry and exit of matter but would allow the entry and exit of energy. Now class, last time in our flip session, i-introduce ko sa inyo yung iba't ibang klase ng cycle. So we have the carbon cycle. So this is your carbon cycle. The natural carbon cycle. Meron din tayong carbon cycle na merong impact in human. We also have the phosphorus cycle. In-introduce ko rin sa inyo yung sulfur cycle. Nitrogen cycle. So this is your nitrogen cycle. And water cycle natin, of course. We should not forget the water cycle. Okay, so those are the different cycles I introduced to you. And now, class, if you would observe, pwede nating maklasify yung cycle sa dalawa. And yung classification niya would be based on its reservoir. Again, yung classification ng cycle natin would be based on its reservoir. Okay, pag sinabi nating reservoir, ano ba yun? When we are speaking class of reservoir, we are speaking actually of the storage, saan natin ini-store yung material. Ulitin ko ha, when we are speaking class of reservoir, we are speaking of the storage or saan natin ini-store yung material. And class, tatandaan ninyo, class, na ang ating biogeochemical cycle, pwede siyang mahati sa dalawa depending kung anong reservoir nila, saan natin ini-store yung material. Meron tayo class, biogeochemical cycle na tinatawag nating atmospheric cycle. You have what we call class as your atmospheric cycle. At meron class tinatawag tayong sedimentary cycle. We have what we call class as your atmospheric cycle. At meron rin tayong tatawag na sedimentary. Sedimentary cycle. So anong pagkakaiba ng atmospheric cycle and sedimentary cycle? So magkaiba sila ng reservoir. Obviously, sa atmospheric cycle, ang storage natin would be the atmosphere. Again, our storage would be the atmosphere, at in sedimentary cycle, ang inyong reservoir is the geosphere kasi nga sediment, meaning durog na bato, meaning yan lupa, no, disintegrated rocks, or our land. We are speaking of sedimentary as land, no. So technically dito sa sedimentary cycle, ang storage ninyo will be the land itself, no, yung lupa. And in atmospheric cycle, ang storage ninyo, ni-store ninyo yung material sa atmosphere. Okay, let us try to examine, no, the different cycle, and let us classify whether the cycle will fall under atmospheric or sedimentary cycles. Whether it would fall under atmospheric or sedimentary yung cycle natin. Okay, let's try. Unahin natin water cycle. Ano ang reservoir ng water cycle? Jalen. Saan ini-store yung water? Anong storage form niya?
Sedimentary, sir.
Nagiging part ba ng lupa yung liquid water dyan? Sige nga. Where do you store water dyan? You store it where? It is stored as... How do you store water? Kayo, hindi kayo
Atmosphere, sir.
Okay. Sure ka? Ano ba talaga, Jalen? What's your answer? Sedimentary or atmospheric yung cycle natin?
Atmospheric,
I mean,
sir.
water cycle natin. Okay, correct. No? Water is an atmospheric cycle since ang reservoir ng water is in the atmosphere. No, it is converted into water vapor, and water vapor is its storage form na nai-store sa ating atmosphere. Okay, let us go to nitrogen. Sige nga. What about nitrogen? Princess. Nitrogen, is it stored in the atmosphere or sa geosphere? Princess.
Sedimentary.
Nitrogen? Sedimentary ba ang nitrogen? Saan na-store ang nitrogen? Ano ang most stable form ng nitrogen? What's the most stable form of our nitrogen, Princess? With class, nitrogen would be what? Would be stored where? Saan na-store nitrogen? Atmosphere pa rin yan. That is why it's an example of an atmospheric cycle kasi ang storage niya or reservoir niya would be atmosphere. That's why we consider nitrogen cycle as an atmospheric cycle. Oh, next, carbon dioxide. Sean. This
Sir.
is easy, ha? Carbon dioxide, what kind of cycle it is? Atmospheric or sedimentary?
Atmosphere.
And also, that would also include oxygen, no? Both of them are considered as atmospheric cycle, yung carbon dioxide oxygen cycle kasi their reservoir would be your atmosphere. Now, what about phosphorus, class? Paano yung phosphorus? How about your phosphorus? Is it ang reservoir niya ba ay atmosphere or geosphere? Plus, Samantha Cruz, ang phosphorus, saan kaya siya ini-store? Sa atmosphere or sa geosphere?
Sa sedimentary, sir.
Correct. This is an example of a sedimentary cycle since no ang storage ng ating phosphorus would be the rocks, no, or the geosphere. Thus, it would fall under your sedimentary cycle. Ganun rin, class, yung sulfur natin. Remember na yung sulfur, no? This is the primary gas of your volcanic eruption, and because of that, meaning it is stored in the geosphere. The sulfur is an example, or the sulfur cycle rather, is an example of a sedimentary cycle. Now, the question is, paano natin mako-compute yung time na ginugugol nila sa kanilang reservoir? Okay, I will show you an illustration to understand what I'm saying. So, for a while, class, give me 2 minutes, may i-chat lang ako kasi may nagtatanong sa akin. Saglit lang for a while. Thank you. Okay, so let's continue. Sorry for the interruption. No, someone is asking kasi about the Miss UN. So let's continue. Where did we stop? No, we stopped classifying the different cycles. No, whether it's atmospheric or sedimentary. No, so let us Okay, so let us examine an example of a cycle. So for example, class, this is the water cycle. Jalen, sige nga. What I'm showing you on the screen right now is your water cycle. Sige nga, saan may store yung water? Saan yung pinaka-reservoir niya? It will be stored where, Jalen? In this case. Saan?
Atmosphere. Hindi, sa
Okay.
ocean.
Jalen, sabi lang natin saan ang reservoir ng water. The reservoir of water will be in
Atmosphere, sir.
atmosphere. So it will be stored in the atmosphere. Now, the thing is, meron siyang amount of time na gugugulin sa atmosphere natin. Yung material ninyo, such as for example, water, and since ang reservoir niya is the atmosphere, there is a certain amount of time na yung water ninyo mag-i-stay dito sa atmosphere na to. At ang tawag kasi sa amount of time na mag-i-stay yung water ninyo or yung material ninyo sa inyong reservoir, tinatawag yung class as your residence time. No? It is called as your residence time. So class, when we are speaking of residence time, class, we are actually speaking of the amount of time, class, where the material would stay on its reservoir. Okay, so let's go here. Okay. So meron tayong natawag na residence time. And when we are speaking class of residence time, yun yung amount of time no, na mag-stay yung material no, in its reservoir. And for example, yung water, if it's reservoir or storage class with the atmosphere class, there will be a certain amount of time na yung water ninyo mag-i-stay yun sa atmosphere. At ang tawag class sa amount of time na mag-i-stay yung material dun sa kanyang reservoir, tinatawag yun na residence time. Now, merong mga material na maikling residence time, no? And example lang would be water. Water would have a very short residence time. At dahil may clearing residence time ng water sa atmosphere, madali siyang palitan ng water ulit. No? Madali siyang mapalitan ng water class over time. Meron din ng material na ang residence time ay napakatagal. And one example nun, class, one example of material na napakatagal ng residence time would be carbon dioxide. No? So, let us recall, Jalen, no? Saan ang reservoir ng carbon dioxide dyan? What is the reservoir? Atmosphere. And the thing is about carbon dioxide, matagal yung residence time ni carbon dioxide sa atmosphere mo. So meaning it would take a long years, no? Matagal na panahon na mag-i-stay si carbon dioxide sa inyong atmosphere. Ano kayang consequence nun pag mahaba yung residence time ng material? What would be its consequence? Anong consequence na palagay niya? Sige, isipin nyo, matagal na i-store or matagal yung residence time ni carbon dioxide sa atmosphere. Ano kayang consequence nun? Kung mahaba yung residence time ng isang material, what is its consequence, class? Anong pwede niyang maging consequence if the material would stay for a long period of time sa atmosphere? For example, carbon dioxide. Carbon dioxide would take long, no? Sa atmosphere natin, it would stay long sa atmosphere natin. It would take a long period of time to stay in the atmosphere. And if that's the case, ano kayang consequence, no? Anyone? Princess, ikaw palagay mo, anong consequence, no?
Matagal po yung process.
Oo, so kung matagal ang process, anong consequence na? Matagal nga mag-i-stay yung carbon dioxide sa atmosphere mo kasi nga tulad na sabi ko, long yung residence time ng carbon dioxide sa atmosphere. And if that's the case, anong consequence mo?
Maiipon?
Correct, pwedeng maipon no, yung material. And in our case, no, masama bang masyadong maraming carbon dioxide sa atmosphere? Yes or no, class? Masama or hindi? Grade 12, ay grade 11, masama ba may ipon yung carbon dioxide sa atmosphere, Princess?
Yes.
Oo, kasi di ba remember that carbon dioxide is an example of a greenhouse gas. Ang carbon dioxide ninyo is an example of a greenhouse gas. And pag masyadong maraming greenhouse gas na present sa atmosphere natin, it can contribute increased global warming. Wala namang problema sa global warming. Need ang global warming. But the problem is nag-a-accelerate yung pag-init ng planet Earth due to the amount of greenhouse gases. No? Pag masyado na marami. In our planet today, masyado tayong maraming greenhouse gases, specifically masyado tayong maraming carbon dioxide emission to the point na na-increase natin yung global warming. Instead na natural lang, yung pag-increase niya, ang increase niya is sobra-sobra. And that could be very dangerous in terms of planet Earth. So nakita class. So if you would look at it, kung titignan natin, merong consequence yung long residence time. And one of its consequence class is in carbon dioxide. Pag masyadong isipin ninyo, matagal yung residence time ng carbon dioxide sa atmosphere and mabilis yung pag-produce natin carbon dioxide, what will happen is that maiipon yung carbon dioxide sa atmosphere, thus contributing more to the accelerated global warming. Nagkakaroon tayo ng tatawag natin accelerated global warming. Okay, now class, how do we compute, no? Paano natin kino-compute yung residence time na to? So for the formula of residence time, it's already given in the presentation. If you would see, residence time is equals to reservoir divided by flux. No? Kapag sinabi niyo reservoir, gano'ng kalaki yung reservoir, what's the volume per reservoir, divided by flux, gano'ng karaming material yung nag-enter at nag-exit ng reservoir. Okay, sige, I will show you an illustration on how will we do that, how will we compute for the residence time na tinatawag natin. So tatandaan ninyo, to compute for the residence time, no? Again yung to compute for the residence time, pwedeng ang gawin natin, we have the size, no? Or the volume, no? Let's just have volume, I think. Volume is a better term. Volume of reservoir divided by yung bilis ng pagpasok ng material or paglabas ng material. Thus, you can divide it by the rate of influx. No? Pwedeng rate of influx or amount ng material na pumapasok do sa reservoir. Or if you don't want to use the influx, pwede mo rin naman gamitin yung efflux. No? So we have volume of reservoir. We have volume of reservoir divided by rate of efflux. And pag sinabi nyo class na rate of efflux, ito yung bilis class ng paglabas ng material from the reservoir. So these are the ways class on how will you calculate the residence time of a material. Okay, let's try to compute for the residence time. Okay, let us look at this nitrogen cycle. So technically what you're seeing right now is a simplified form your nitrogen cycle. So ito yung mga size ng reservoir. So ito yung atmosphere ninyo. So ang size ng reservoir ninyo is 3 times 10 raised to 20. Ito naman sa lupa, no? 7 times 10 raised to 15 lupa. So waters ninyo sa surface and sa deep waters ninyo. Ngayon, ito na may rate ng influx at efflux. Pag influx yung material na nag-e-enter, ayan. No? Yan, this is an influx kasi may entry of material sa atmosphere, influx rin. Ito naman efflux. Palabas yung material from your atmosphere. Okay, let's try to solve an example. Let's try to solve class for the residence time of nitrogen. Mag-solve tayo ng residence time ng nitrogen. Okay, Sean, can you turn on your mic? Sean, can you turn on your microphone?
Sir.
Okay, let's try to solve for the residence time. Remember, Sean, na ang formula mo for residence time is the volume per reservoir divided by the rate of influx, or kung ayaw mo influx, pwede mo gamitin ay rate of efflux. Okay, so let us say we are solving for residence time. Na yun, Sean, the question is, ano ang reservoir ng nitrogen? What's the reservoir of your nitrogen?
7 times 10 raised to 12.
Hindi. I'm asking, ano ang reservoir ng nitrogen? Sean, anong reservoir ng nitrogen? Wala akong hinihinging value. I'm just asking you, ano ba ang reservoir ng nitrogen, Sean?
Atmosphere, sir.
Atmosphere. So technically, we're going to look at the atmosphere, no, to compute for the residence time of the nitrogen in its reservoir. Ngayon, according to our formula, we need to get first the volume of reservoir. So anong volume ng atmosphere mo dyan? Ng nitrogen sa atmosphere? Sean?
3 times 10, sir.
Oh, yes, you're correct. 3 times 10. No? Times 10 raised to 20 tons to class. So this is expressed as tons. No? Now, divided by. So, pwede kang mamili, pwedeng influx or efflux. Anong gusto mong gamitin? Are you going to use influx or efflux?
Influx, sir.
Okay, let us use influx, no? Gamitin natin is influx. Let me check the units lang kasi mamaya mangyari ako mali ako ng number of years. Let me check lang kung anong ginamit na unit sa diagram na for a while. What unit did they use? Okay, per year lang. So, it's tons per year. Okay, so let's continue, Sean, no? Okay, so pag sinabi mo influx, ano yon? Material na nag-enter or nag-exit ng atmosphere? Influx. Sabi mo influx eh. Ano ba yung influction? Those are what? Materials that what? Enters or exit the atmosphere. Influx. Anong sabi ko regarding the influx sa inyo?
Going inside, sir.
Ano yung influx, Sean? Mag-enter or mag-exit ng atmosphere?
Mag-enter, sir.
Mag-enter, correct. So, ano yung mga ano dito yung mga amounts, class ng nitrogen na nag-enter sa inyong atmosphere? So, we have, sige nga, ano yung mga influx rate dito? Look at the diagram, ano yung mga influx rate nyo sa atmosphere?
Nitrogen on land, sir.
Knock. Tinatanong ko lang yung rate. Ano yung mga rate of influx dito? Ano yung mga value? Bigay mo yung value para hindi ako malis.
7 times 10 raised to 15, sir.
Saan mo kinuha yung 7 na volume yan ng lupa. Ang tinatanong ko yung influx, yung material na nag-enter sa atmosphere. May arrow na nga eh. That would give you a clue of rate.
5 times 10 raised to 12, sir.
So, itong 5 times 10 raised to 12, ito yung nitrogen na nanggagaling saan? Sean? Nitrogen na nanggagaling saan? According to the diagram. Sa lupa. These are the nitrogen coming from the land going to the atmosphere. So, we have 5 times 10 raised to 12 tons per year. Aside from that, meron pa bang ibang rate of influx? Sean? Aside from that, meron
Yes,
pa
sir.
ba? Saan galing?
Sa dagat, sir.
Sa tubig, okay. Gaano kalaki yung nitrogen na manggagaling sa water?
7 times 10 raised to 12.
Okay. Plus, so meaning add mo plus 7 times 10 raised to 12 tons per year. Sige nga. Actually, this would let us cancel tons and matitira is the number of years. Okay, Sean. Hindi ko rin sure ha. Check natin. Wala na ba? Wala na, no? Wala na mag-e-enter sa atmosphere ninyo. It's not the last one. Sean, may mag-e-enter pa ba sa inyong atmosphere? Meron, wala na.
Wala na, sir.
Wala na. So I think we can compute now for the rest. Time. Sige nga, Sean, gonna compute how much year would it take class for nitrogen to stay in your atmosphere? Kindly compute.
Several copyright licenses, licenses.
What did you get, Sean? Ano yung residence time niya? Anong residence time niya, class?
We can also use this. Attribution.
Sean, are you done computing? Sean.
Hindi pa, sir. Right.
Okay, sige lang. Take your time.
Derivative works, we can change. Okay. Share alike. zero viewer, okay? Sun here and you can change. However, you must share, okay? And then other people use your viewer to access us. So these are the five things. So we have here the traditional water ride that we use adapted or the niche without meters.
Okay, what did you get?
And we have this one. What does it like? All the
Anong nakuha ninyo?
is protected under rights. Okay, and we have this. Where we use but only under certain circumstances, creators set rules for the way the world is used. Okay? But that's
Sean, what did you get?
only for creators that choose it with designate as and we have of course the
Sean, what did you get?
it's not already technical right? It's a product of one's person's imagination or creation, but it's already considered a public domain.
Parang mali nakuha ko, sir.
Gano'ng kalaki? Anong
Hindi
nakuha
siya-
mo?
Ano lang, sir? 4 times 10 raised to 7, sir.
Bakit? Okay, let's try to 7 years. Sige, let's try to confirm. Tama, pareho kayo na nakuha, class. Did you get the same value? Grade 11? Pareho lang yung value na nakuha ninyo.
No,
Grade
sir.
Anong nakuha niyong value sa
Ano, yung akin po, 4 times 10 raised to 32.
to 32? Sige nga, let's compute. Compute din ako for clarity. For a while. Pero parang tama tong 7. Raised to 7 kasi masyadong mali. Baliktad yung nangyari sa isang mas masyadong malaki yung kinalabasan. Dapat siya mas maliit. Tama to, Sean. This is correct. So meaning it would take 4 times 10 raised to 7 years, no? Plus, para magstay yung nitrogen sa atmosphere. And ano masasabi mo, Sean? Mahaba or maikli yung residence time niya?
Mahaba, sir.
Mahaba, matagal, di ba? It would almost ilang millions yan. Sige, ilatag mo. 1, 2, 3, 4, 5, 6, 7. Let's look. Di ba? 4 million years. Hindi nyo, yung nitrogen ninyo to stay in the atmosphere, it would take 4 million years. Ganun katagal. So, it's a very long residence time. Kaya nga class, di ba? One of the problem that we face is the emission of carbon dioxide. Kasi it would take million of years to remove carbon dioxide from the atmosphere. And yet, ang bilis nating magdagdag ng carbon dioxide sa atmosphere. And dahil doon, no, we cannot avoid the consequence of having this accelerated global warming. Okay, class, did you understand the matter in your, did you understand class matter in your, what do we call this, in your Earth system? Naintindihan? Bago tayo mag-proceed sa energy, we're done with matter. Did you understand matter in your energy system class? Before we proceed. Okay, so now class, let us go to your energy, no? Yung energy natin in the Earth system. Okay, let me share to you my screen. Medyo complicated nga lang yung equation for energy, pero do not worry, we will dissect this equation one by one. Kasi marami tayong forms, no, ng energy that enters and exit the planet. Supposedly, it should be easy. Supposedly kasi, ang gagawin lang natin is aalamin natin yung amount ng energy na pumasok sa Earth, no, at yung amount of energy na lalabas sa Earth. We will just identify the amount of energy or the incoming solar energy towards the Earth and the outgoing energy from the Earth. Supposedly, para malaman natin yung net amount of energy. So technically, wait lang, let me change muna. Let's change muna the screen. Okay. To get the net energy, no? Para makuha natin yung net energy na planet Earth, ang kailangan natin gawin is we should what? We should subtract the amount of incoming energy or the influx na lang siguro, mas better yung influx, no? We must subtract, no, the influx, yung energy na pumasok sa Earth, that would be the influx, minus the energy, no, na lalabas sa Earth, that would be the efflux. So, para makompute natin yung net energy, to compute for the net energy, again, to compute for the net energy sa Earth, ang gagawin lang talaga natin is to subtract the amount of energy na pumasok, yung influx, sa kay amount of energy na mag-exit, no? So that's how we compute for the net energy na tinatawag natin. Pero later, hindi na marami tayong kasing klase ng incoming energy at marami tayong klase ng outgoing energy or marami tayong klase ng influx energy at efflux energy. That's why more complicated, mas komplikado dito yung equation ng ating ating computation for the net energy. Pero class, let us go to the condition that we have. Supposedly, ganito yung case natin. Dapat, class, sa planet Earth, yung amount ng energy na papasok should be equals to the amount of energy na mag-exit. Pero palagay nyo, ganun ba talaga nangyayari? Equal ba yung nagiging amount ng energy na pumapasok at nag-exit sa planet Earth? What do you think? Any idea? Equal kaya amount ng energy na pumapasok at lumalabas sa planet Earth? Supposedly, yung amount dapat ng amount of radiation or amount of energy na pumapasok sa Earth should be equals to the amount of energy na lalabas sa Earth. But the question is, palagay nyo, ganito nangyayari. What do you think? Samantha, Arcelia. Palagay mo ganun yung nangyayari, Sam?
Sir, siguro hindi.
Okay, actually hindi. That is why we need to compute pa for the net energy. Kasi kung ganun yung nangyayari, kung equal yung amount ng incoming energy at outgoing energy, dapat ang alam nating balance would be zero. Zero yung net energy. But in reality, class, hindi ganun nangyayari. Hindi equal yung amount ng energy na pumapasok at lumalabas. At dahil dun meron tayong net energy, and this net energy, class, yan yung ginagamit ng planet Earth to drive weather and climate. So meaning yung weather condition nyo at climatic condition nyo, nakadepende yan sa net energy. Kasi, in reality, dapat kasi balance yung amount ng energy na papasok at lalabas. Pero dahil hindi siya nagiging balance, nagkakaroon ng net energy. And dahil nga may net energy kayo, this net energy will drive the climatic and weather condition in your Earth system. Supposedly, pero hindi ganito nangyari. And dahil hindi ganyan nangyari, we need to compute for the net energy. So ito yung supposedly madali lang to. Later on makikita nyo bakit naging ganito ka-komplikado equation. Pero in reality, ang ginawa lang talaga dyan, minus nyo yung amount ng energy na papasok sa Earth sa kay amount of energy na lalabas sa Earth. Pero kasi nga maraming klase na incoming energy at maraming klase na outgoing energy. That's why the equation becomes like this. So this is the right side of the equation. Dalawang equation to. This is the first equation. At ito na may pangalawang equation to compute for the net energy. Okay, let us discuss bakit naging ganito yung equation natin. Pero do not be scared of that. It's just, in reality, it's just the difference between the incoming energy and the outgoing energy. In order for you to understand that, we need class to consider, kailangan natin i-consider class yung iba't ibang klase ng energy na papasok at lalabas sa Earth. And before we do that, let me represent to you the cartoons, no, na gagamitin ko sa presentation na to so that you will have a better understanding, class, of the different kinds of energy na papasok sa kalalabas sa Earth. Okay, this is Earth surface, no? This is a representation of the Earth's surface. Ito naman, this is the atmosphere. Tapos yung dot dyan, mga aerosols, meaning na aerosols, yan yung mga particles na present sa atmosphere ninyo. So this is the Earth, of course, no? Ito clouds. Okay, so let's begin with this one. Okay. So, balik tayo dito. Tatandaan ninyo, class, lahat ng pumapasok na energy sa Earth, maikli yung wavelength. At tawag sa kanila dahil maikli yung wavelength, we call them a shortwave radiation. Okay? Dahil maikli yung wavelength ng mga energy na pumapasok sa planet Earth, tinatawag natin sila, class, as shortwave radiation. So what do we expect is that lahat ng pumapasok sa planet Earth na energy coming from the sun would have short wavelength, no? So we call them a shortwave radiation. At itong mga shortwave radiation, they are the incoming energy. Ayan, no? If you would see here, this is the incoming energy and they are called a shortwave radiation dahil may clear wavelength nila. And in that case, they are in the form of either visible light, no? Visible light. Ultraviolet, no? Ultraviolet. And your infrared, no? Sila yung mga shortwave radiation. Sila yung mga radiation na pumapasok sa planet Earth or the energy that is incoming, the energy that enters planet Earth, and usually they are characterized with short wavelength. That's why tinatawag sila shortwave radiation. Ngayon naman, class, lahat ng energy na lalabas sa planet Earth, mahaba yung wavelength. That's why you call them as long wave radiation. LW stands for long wave radiation. And itong mga long wave radiation na to, mahaba yung wavelength nila and they are characteristic of outgoing energy. Yung mga lumalabas sa energy from the planet. And they are usually in the form of radio waves, no? Madalang pa nga yung microwaves, kadalasan they are radio waves. And now, to represent your shortwave radiation, para ma-represent natin yung shortwave radiation, I would represent it like this one. Ngayon, class, the thing is, itong shortwave radiation, pwede siyang direct. So, meaning ng direct, pwede siya mag-hit ng ground directly. Ayan, directly yan. So, we have direct shortwave radiation. So, how do we know na meron tayong direct shortwave radiation? Malalaman natin na may direct shortwave radiation pag nakakabukay ng shadow. Diba, for example, di ba, yung araw, pag nasinagan kayo, nakabukay ng shadow, meaning those are direct shortwaves. And in that cases, no, pag direct yung short waves natin, yun nga, tulad ng sabi ko, you are able to form shadows due to high intensity of light. Ngayon, hindi lahat ng shortwave radiation ay direct. Sometimes kasi pwedeng mag-scatter, no? Pwedeng mag-scatter yung shortwave radiation natin. Tulad sa nangyari dito. Ang nangyari dito yung shortwave radiation dahil dumaan siya sa atmosphere na puno ng dust, puno ng particles, nangyari, nag-scatter siya. At pag nag-scatter siya, hindi na siya tatawagin na direct shortwave, tatawagin niyo siya as diffuse shortwave. Ayan, natingnan niyo. Ano nangyari? Yung araw ninyo nag-scatter, ng araw tuloy, yung radiation ninyo, instead of becoming direct shortwave, nangyari, nag-diffuse siya, nag-scatter siya. And pag nag-scatter siya, no, tinatawag tong diffuse shortwave, at ito, you cannot form shadow na. Di ba, class, may araw na hindi ka nakaka-form ng shadow, and yung araw, di araw, may light, no? May light, no? Or may radiation coming from the sun where you do not form shadows. And if that is the case, pag hindi kayo nakabuo ng shadows, class, meaning the shortwave radiation is not direct, instead diffuse siya. So yun yung pagkakaiba ng dalawa. Ito direct shortwave, nakabuo ka ng shadow, no? Dito naman, diffuse shortwave kasi nag-scatter na yung shortwaves ninyo, thus you are not able to form shadow. So dito, kaya nag-scatter siya kasi dumaan siya sa atmosphere that is full of particulate matter. Thus making it scatter, nagkakaroon tayo ng diffuse shortwave na tinatawag natin. And plus, if you are going to go back to this equation, saan si direct shortwave? Saka si diffuse shortwave. Ito yun. Yung capital Q, that is direct shortwave. Tapos yung small q, that is diffuse shortwave. And if you would observe, pareho siyang naka-plus. Bakit naka-plus siya? Kasi incoming siya. Incoming energy siya. It's an incoming energy. Naiintindihan, class? Do you follow so far? Yes or no?
Yes,
Yes.
sir.
So, meron tayong direct shortwave and direct shortwave and diffuse shortwave. Now, class, the thing is, yung direct shortwave ninyo, yung direct shortwave ninyo, pwedeng magkaroon tayo ng tinatawag na albedo effect. Again, sa direct shortwave ninyo, pwede tayo magkaroon ng tinatawag na albedo effect. Kung saan ka sa albedo effect, nagre-reflect yung light, nagbabounce siya. So instead na maging incoming, pag nag-bounce siya, magiging outgoing siya. At itong albedo effect na to, pwede siya mangyari sa atmosphere at pwede siya mangyari sa lupa. So let me show you a picture of what we call as the albedo effect. Okay, let me show you an example of an albedo effect. Ayan. So, anyways, no, bago tayo magpunta sa example ng albedo effect, what I'm showing you right now is yung nangyaring albedo. So, nangyari dito yung shortwave, yung direct shortwave nyo, instead na maging incoming, naging outgoing siya. Bakit? Kasi nag-bounce siya. It reflected. Since nagkaroon na reflection, it bounced back. No? And pag nag-bounce back siya, pwede siya maging outgoing. So, we call that as your albedo effect. Okay, let me show you a picture. May natin discuss yung implications, no? Okay, let me show you this one. Ayan. So, tignan nyo. Yung direct wave na tumama sa lupa, kindly look at this, yung direct wave na tumama sa lupa, pwede siyang mag-bounce back. No? So, yung iba, pwede siyang mag-hit directly sa lupa. Yung iba naman, pwede siyang mag-bounce back. At pag nag-bounce back siya, tawag doon is albedo effect. Nagkaroon na reflection light. Sa atmosphere din, class, ganun din nangyayari. No? Yan. Sa atmosphere, pwede rin magkaroon ng albedo effect. Pwede rin mag-bounce back yung direct shortwaves na tatama sa clouds or particulate matter. And class, so technically, to summarize it all, pwede mangyari albedo effect sa atmosphere or sa lupa natin. And plus, kindly keep this in mind na ang albedo, no, usually ang albedo, it is expressed as this coefficient. It can be expressed from 0 to 1. Pag 1 yung albedo, meaning mataas ang albedo effect niya, nare-reflect most ng light. Pag 0 naman, wala siyang nare-reflect na light. So, yan yung pagkakaiba. So, for example, meron tayong puting concrete saka itim na concrete. Sinong mas mataas ang albedo? Sige nga, let's try. Jalen. Let's look at
Yung
this one,
black.
Ja. Okay, may puting concrete at black concrete. Sino mas mataas ang albedo? Yung puti o yung black?
Yung black po.
Albedo, ha? Ano ba yung albedo? Ja, ano yung albedo? Anong sabi ko? Ano yung albedo niya? Jalen, ano yung albedo na yan?
Sir,
Ano yung albedo na?
yung
What?
nagba-bounce back po, sir.
Ano nga
Yung-
nagba-bounce back? Yung light.
Yung light.
So, saan magba-bounce back yung light? Sa puting concrete or sa itim na concrete?
Yung sa white concrete po, sir.
O, sa white concrete, kaya nga siya white meaning nagba-bounce back yung light doon. That's why it's color white. So, sa black concrete, nangyari dito, hindi kayang mag-bounce back ng light, thus i-absorb lang yung direct shortwave dito. Kaya ang nangyayari dito sa puting concrete, dahil nga mataas ang albedo niya, magba-bounce back yung light niyo. That's why it's color white. No? Due to the albedo effect or yung pag-bounce back ng direct shortwave dito sa white concrete. And in this case, dahil nga nag-bounce back lang yung energy, hindi na-absorb yung energy, malamig siya. Unlike sa black concrete dito, dahil nga walang albedo, zero yung albedo nyo dito, nangyari, instead na mag-bounce back yung light energy, inabsorb lang siya, thus making it a hotter surface, no? Once na naka-receive siya ng direct shortwave. For a while class, may tatanong lang ako. Okay. So, naiintindihan, class, yun yung tinatawag nating albedo effect. Kasi that is why nga rin, di ba, pag yung mga engineer, pag nagde-design sila ng daanan, anong ginagamit nila? They use white concrete over black concrete kasi napakainit ng black concrete. Napakainit niya kasi nga zero yung albedo niyan. And pag zero yung albedo niya, it can absorb it or it will absorb energy once it receive direct shortwave. That's why mas preferred ng engineer ang white concrete over black concrete. Okay? So I think we are clear with this albedo effect, no? Okay, now let's go. Okay, let's go plus to this table and let's try to analyze the albedo. Okay, tatandaan niyo sa forest, mababa yung albedo. Tapos sa snow and peak clouds, mataas sa albedo. Sige nga, unahin natin yung forest. Bakit mababa yung albedo ng forest? Palagay niyo. Bakit mababa yung albedo niya? Meaning nun hindi nakaka-reflect ng light or hindi nagba-bounce back yung light sa forest. Bakit kaya? Samantha Arcilia, why do you think?
Sir, sa forest, kaya mababa yung albedo kasi ina-absorb doon ng...
Correct. Ina-absorb yung light doon. Instead na mag-bounce back yung light, no, yung direct shortwave ninyo, direct shortwave is absorbed in forest. Kasi yung mga puno doon would absorb direct shortwave. Samantala sa snow and clouds, bakit mataas albedo niya? Obviously, class, it is not capable to absorb light energy, thus mangyari magba-bounce back lang yung ating shortwave pag nag-hit sa kanila. And class, just for a fact, no, the average albedo of planet Earth is 0.30. Okay, may tanong ako. So, ito class, yung Amazon rainforest before and after. So, dati mas maraming puno and afterwards, due to deforestation, nabawasan siya. So, anong palagay niyo mangyari sa albedo? Anong mangyari sa albedo? Of course, yung albedo tataas. And in this case, anong mangyari sa Amazon rainforest? Will it absorb more shortwave or less shortwave kung nagkaroon ng deforestation? Samantha Arcilia.
Less shortwave kasi.
Okay, less shortwave. Mas konti shortwave na ma-absorb kasi nabawasan nga yung vegetation. Okay, now, another thing that we need to consider is this one. So, tatandaan ninyo, class, ganito. Let me show you this one. Okay. So, aside from albedo, kunyari, ayan, nakita nyo to. Kunyari, class, yung shortwave inabsorb ng lupa. Aside from albedo, pwede rin mangyari, pag inabsorb yung energy, magre-release yung lupa or yung atmosphere nyo ng energy, and this energy release will be an outgoing energy. And kadalasan yung release ng energy, no, is mahaba yung wavelength niya. Mas mababa yung amount of energy. And tong phenomenon na to, class, tinatawag to the phenomenon of black body radiation. Kung sa black body radiation, sinasabi dyan na pag yung isang bagay nag-absorb ng energy, in return, magre-release din siya ng energy. Na-experience nyo yan, di ba, class, pag tumakbo kayo, after nyo tumakbo, ang init ng katawan ninyo. The reason for that is, class, nagre-release kasi yung katawan ninyo ng energy. At ang tawag sa energy na re-release niya, dahil mahaba yung wavelength nun, tinatawag yun na long wave radiation. No? So, rene-release yung energy niya in the form of long wave radiation. Tulad nito, kunyari yung lupa, nakatanggap ng short wave radiation. So, ang two possible effect, pwedeng mag-reflect yung short wave or another thing, pwedeng magkaroon ng production, magre-release kayo ng long wave radiation. A type of radiation or energy na mas mababa yung wavelength. So, tinatawag yan na long wave radiation. Ayan, no? Tingnan nyo ito. Upon absorption, nag-release tayo ng long wave radiation. And this long wave radiation is an outgoing energy. So technically, in this, we would represent class the long wave radiation as like this one, At itong long wave radiation ninyo, pwede siyang mag-exit, pwede rin siyang bumalik sa planet Earth. Paano? Paano nangyari yan? Sige, let me show you this one. Okay. Ito, this is just an outgoing long wave radiation. Diba? Wait lang. This is just an outgoing long wave radiation. Ayan, pag nag-absorb ng energy, lupa, pwede siya mag-release ng long wave radiation. Ganun din atmosphere. Especially matter sa atmosphere, pag nag-absorb sila ng short wave, pwede sila mag-release, pwede rin mag-release ng long wave radiation. No? And pwede rin mag-release ng long wave radiation. Yung atmosphere, wait lang, let me show you this one. Okay. Do I have illustration for that? Ayan, tignan nyo. If you would observe, no, itong atmosphere ninyo, it can also release long wave radiation upon absorption of direct short wave. And if that's the case, no, this will become an incoming energy instead of outgoing energy. No? So both yung lupa at atmosphere ninyo pwede mag-release ng inyong long wave radiation. Now the thing is, ganito yung nagiging fate ng long wave radiation natin. Some long wave radiation, no, some long wave radiation, natatrap sila sa atmosphere. Tawag doon is greenhouse effect. No? Some long wave radiation will be trapped in the atmosphere. So tinatawag yan na greenhouse effect. Yung ibang long wave radiation, no, pwedeng mag-exit naman, no? At pero yung iba pwede rin bumalik pabalik sa lupa. Ayan. No, may mga times na bumabalik rin siya sa lupa. Aside pa dyan sa long wave radiation, no, aside pa yan sa long wave radiation na rinirelease ng atmosphere. So those are the possibilities, class, for your long wave radiation. And class, if you would look at this, so let's go back to the equation here. Itong A, albedo effect, kaya siya minus kasi outgoing siya. Ayan, no? Lumabas kasi ito nag-bounce back, nag-reflect, outgoing siya. Ngayon, may mga long wave radiation na palabas, no? Outgoing, LU yun, at yung mga long wave radiation na pabalik sa lupa, that would be LV. So technically, ano lang ginawa natin, itong tatlong to, yung direct shortwave, diffuse shortwave, saka itong bumalik na long wave radiation, these are the incoming energy. And itong naka-minus, these are the outgoing energy, nag-reflect by albedo effect, yung palabas na long wave radiation. That is your outgoing energy. And that is your equation for the energy balance of the Earth. Nakita, it's just simply what? To make it simple, it's just, you will just subtract the incoming energy and the outgoing energy in that. Magsasubtract lang talaga kayo ng incoming and outgoing. Now, class, ito pa lang yun. Itong side pa lang yun ng equation natin. So, if you're going to go back to this equation, dito pa lang yun. We have just discussed this part of the equation. May isa pang side yung equation, itong part na to. So, we are going to discuss also this one. Anong meaning ng side na to ng equation? Bakit pwede rin natin gamitin itong equation na to to compute class for the net energy. So itong side na to, it refers to three things. No? G is the amount of internal energy of the Earth. Meron kasing tinatawag na internal energy. Yun yung amount ng stored energy sa Earth, and that would be G. Ngayon, itong H na to, LE, no? Itong H class would stand for what we call class as sensible heat, yung H. At yung LE niya naman, it would stand for latent energy. No? Or latent heat na tinatawag. So, let me give you the definition. G is the internal energy. So, pag sinabi niyo internal energy, the amount ng stored energy. Again, pag G, it's the amount of stored energy present in Earth. That would be G. No? Yung H nyo naman, tinatawag yung class sa sensible heat. No? At yung sensible heat, ginagamit yan para pataasin yung temperature. Kung heat energy na to, kung sensible heat na yan, ginagamit yan para pataasin yung temperature ng matter. So that's your sensible heat. Meron din tayo class na tawag na latent heat or the latent energy. And when we're speaking of latent heat, ito yung heat energy na gagamitin para magkaroon ng phase change, para yung solid maging liquid, yung liquid maging gases. No, we call that as your latent heat or latent energy. And let us go to that to the part of our discussion. Later on, we will go there. Okay. Okay, dito tayo sa right side na equation. We're going to discuss this right side of the equation. So alam na natin, this is sensible heat, this is latent energy, latent heat, at this is your internal energy. So sa internal energy, yan lang yung stored energy ng Earth. So let us focus on sensible heat and latent heat. No? Pag sensible heat class, let's go to sensible heat. Okay. Okay. Pag sensible heat, tatandaan ninyo. Wait lang may I go first the slide or sensible? I think wala. Let's just go to this point. Ito lang tatandaan nyo, class. No? Pag sensible heat, nagkakos siya ng change in temperature. No? Pag sensible heat, it causes change in temperature. Again, pag sensible heat, change in temperature. Pag latent heat naman or latent energy, phase change lang. Nagpapalit yung phase ng matter. So from solid to liquid, from liquid to gas. So we call that as latent heat. Ha? And last, we are going to look at the equation in order to get the net balance. I-add nyo lang yung sensible heat, no, yung amount of energy no, na nag-cause ng change in temperature, the latent heat or the amount of energy na magkakos ng phase change, plus ano yung stored energy ng Earth so that you can get no, the net amount of energy in planet Earth. Now, in order for you to understand more about the sensible heat and latent energy at paano sila nakaka-apekto sa net energy ng planet Earth, let us examine this scenario. So, tatandaan ninyo, class, let us say meron tayong forest, saka meron tayo ditong desert. Okay, unahin natin sa desert. Sige, let's try Jalen. Jalen, may I call your attention?
Yes, sir.
Jalen, desert muna. Sa desert, meron ba tayong materials kung saan pwede tayong mag-cause ng phase change?
Yes, sir.
Meron, pero marami ba? For example, water, di ba? Ang water, pwede mong i-evaporate yung water so that pag nag-evaporate yung water, it will be transformed from liquid to water vapor or to gas. At anong gagamitin mong heat energy to transform water from liquid to gas? What do we call that heat energy? I just told you.
Latent.
Ano yun? Okay, the latent energy or the latent heat. Now, sa desert, may enough water ba na itatransform tayo to other phases?
Wala po.
Wala masyado. So what do we expect sa desert? Anong mas mataas? Yung heat na nagkakos ng change in temperature o yung heat na nagkakos ng phase change?
Yung sa change in temperature po.
O kaya nga 'di ba, pag umaga sobrang init sa desert, pag gabi sobrang lamig sa desert. Meaning anong mas mataas? Sensible or latent heat?
Sensible heat po.
Correct. Higher si sensible. Now, sa rainforest, remember na yung water, may yung water tuloy, yung plants may water yan. And because of that, pwede mo bang gamitan yun na latent energy to cause transpiration or evaporation of water?
Yes, sir.
And meaning, ano mas mataas sa desert? Latent or latent heat or sensible heat?
Latent heat.
Latent. Oo. So, kung sa forest, latent heat yung higher, sa desert, higher yung sensible heat. Now, let us say, gumawa ako ng project. For example, dito sa Arizona, nagdagdag tayo ng water canals sa desert. Ano kaya mangyayari sa latent heat ng desert na to? Tataas, bababa? Kung magdadagdag tayo ng water canals, what will happen to its latent heat?
Tataas, sir.
At ano mangyayari sa sensible heat niya?
Bababa.
Bababa. So, one-way class, ibig sabihin, one way of cooling deserted places tulad ng Australia, ng Arizona, ang nagiging solusyon nila, nagdadagdag sila ng artificial water system so that mapababa yung sensible heat at tumaas yung latent heat. And if that would be your case, pwede natin mapababa yung temperature changes or variability sa desert regions. Nakuha class. So that's one engineering technique na pwedeng gamitin ng engineers to decrease the temperature in deserts. Okay, let's try to compute gamitin natin yung equation for the net energy. Tignan natin. So technically alamin lang natin outcoming saka incoming radiation. Okay, mamaya na yan. Tingnan natin. Sige, class. Okay, so meaning class, ang pumasok sa Earth na energy is 100. Kindly look at this one Dito ano nangyari? From 100, ulitin ko, gaano kalaking energy yung pumasok Jalen dito?
100, sir.
Okay, tignan mo, ano nangyari dito sa mga radiation na to? Sa shortwave radiation. Anong tawag dito? Pag nag-bounce back?
Albedo effect.
Albedo,
Albedo.
albedo. Albedo. So may albedo ka dito, albedo. So ano nangyari dito? Incoming pa rin ba to?
Outcoming na po.
Outgoing na. So technically at this point, ilan ang outgoing energy mo na shortwave? 3 plus 23 plus 8 is 31. So 31 yung albedo. Yung reflected light waves mo or shortwave radiation, that's 31 yan. Ito, incoming pa rin ba to?
Yes, sir.
Okay. So pwede siyang direct, pwede siyang diffuse, no matter what, no matter what, let us just look at how much energy yung nakapasok dito sa ground natin. In this case. Okay. So, out of 100, of course, nabawasan na to ng 31. So, that leaves us 69. No? From 69, yung iba inabsorb ng atmosphere, 18 joules. So, 18 joules will be absorbed by your atmosphere and also by the clouds. 3 joules naman for the clouds. Or hindi. Buong atmosphere na yata itong 18 joules. Let me check Kung 69 minus 18 Jalen. Tama, iba pa pala. So, technically, 18 joules sumabsorb ng atmosphere, 3 joules sumabsorb ng clouds dito, at ang pumasok lang dito sa lupa, at ocean natin is 48 joules. Do you follow? So, lahat tong portion na to, this will be your incoming radiation. At ito, outgoing to. Do you follow so far, Jalen?
Yes, sir.
Okay, now, let's go to the long wave radiation. So, magpo-produce ka ng long wave radiation, tama? No? You are going to produce long wave radiation pag nag-absorb ka ng energy dito. So, let us say, ang long wave radiation na produce natin is, let us say, 114 joules. This will be the amount of dapat na outgoing radiation. Yun nga lang, yung iba lumabas, ilang joules lang raw yung lumabas dyan?
12 po.
Ilang joules yung inabsorb ng atmosphere sa kanong clouds?
102.
At out of that 102, ilan ang bumalik?
95.
95. No, 95 yung bumalik. Pero out of that 102, meron din lumabas. Tignan natin how much yung lumabas. Ilan daw lumabas?
48, sir.
Wait lang, iba pa to. Ilan lumabas? 95. Sige nga, 95 plus 12. Diyan.
100.
107, di ba? Ba't hindi nag-balance to? 102, 102, dapat 114, correct. So, out of this 102, 95, 95 minus 102, Jale. 7, no? Dapat 7 lang.
Yes po.
Saan napunta yung 7? Kasi ito, long wave na to na produce ng clouds at atmosphere. So, technically, nagstay lang. Nagstay lang sa atmosphere yung 7 na yan. Hindi siya na ibalik dito. Ito naman, these are the long wave radiation na produce ng cloud at ng atmosphere mo. So technically, ito yung total amount of outgoing long wave radiation. So, gaano kalaki yung outgoing short wave radiation, Jack?
Sir?
Gaano kalaki yung outgoing outgoing short wave radiation?
31.
Gaano kalaki outgoing long wave radiation?
69.
69. So, yan yung mga outgoing energy mo. Tignan mo, gaano kalaki na absorb ng lupa?
48.
So, this is your incoming radiation. Nakuha dyan.
Yes, sir.
Minus nung outgoing, gaano kalaki outgoing radiation? Pag inad mo yung outgoing short wave sa long wave radiation,
114.
114 joules. At gaano ka laki yung energy na bumalik from long wave radiation?
95, sir.
As this incoming or outgoing?
Incoming.
Incoming na kasi bumalik sa lupa. So technically, what will be your energy balance? It's 29 joules. So ganun mag-analyze ng ganitong klase ng diagram. You will identify how much shortwave and longwave radiation na pumasok na naging incoming at gaano kalaki naman yung shortwave and longwave radiation na naging outgoing. And from that, you can get the net energy na tinatawag natin. Okay, did you understand it so far? Grade 11.
Yes, sir.